Greetings, Patriots. In this lesson 8, you're going to now just stop and compare some characteristics on proportional representations. So let's just start with our table. So remember, in the past two lessons, we were looking at our change in y over change in x. And again, we're going to do the same thing here. And we've already seen some of these tables. Now we just want to stop and compare them. So if we think about our constant rate of change here, okay, if I'm looking at proportional tables, right, I know if I take the difference, if I want to see what the constant rate of change is in this particular case, what I'm going to do is find the difference, right, the change in y over the change in x. And when I do that in this case, I can see that when I subtract 550 minus 2.75, that's going to give me a difference of 275 over 1, which is just 275, and vice versa. If I take the change in between $8.25 and I subtract 5.5, I'm also going to get this increase of 275 for every one lunch, okay? So now what I'm also going to do, so I can see in this case that my constant rate of change is $2.75 per lunch. But I can also take this ordered pair and divide each one. 275 over 1 equals 275, right? $5.50 for 2 lunches is equal to 275. And then you can check $8.25 for 3 lunches, and you're going to notice that you're going to get also a constant of proportionality, which is 275. So I'm checking constant of proportionality and constant rate of change. In this case, they're both equal, letting me know I definitely have a proportional situation, but more so because of that constant of proportionality. Let's look at this. I'm looking at the number of mules. So that's my domain values, right? And then I'm looking at my y variable of bales of hay. So again, I can take change in y over change in x, and I get a 1 over a 2, so 1/2, right? Change in y over change in x. Let me do the next one. Change in y plus 1 and plus 2. So once again, I get a change of 1 over a change of 2. So it seems like my constant rate of change is 1/2. Now let's go ahead and take our ordered pairs of 2. I'm taking 2 mules, right? Need 1 bale of hay to eat. Well, if I take change in y divided by x, that's going to also be equal to 0.50 or 1/2. Same thing. If I take the next ordered pair of 4 mules need 2 bales of hay, and I divide 2 divided by 4, that's also going to give me a 1/2, which is equal to 0.50, which is what my crock is equal to. So if I check every single ordered pair, I can see that the bales of hay is always going to be half of what the number of mules that I have to feed. So do I have the same constant rate of change, which was 1/2? Do I have a constant of proportionality? I do. And because I have both of those that are equivalent, and when I check my constant of proportionality and I get equal ratios, that is an indicator that I have proportional situations. So if all my ratios, when I divide, are equal, right, I am going to have a proportional situation. If my crock, my constant rate of change, equals my constant of proportionality, that's another indicator that I'm dealing with a linear proportional situation. Now let's go look at 2 graphs that we looked at that were actually proportional, and I think I stated. Once again, I always look to see if these are lines, and they both are. I'm dealing with 2 linear situations, but most importantly, I need your eyes right here. Is 0, 0 a part of each and every single graph? And it is. 0 bags, right, are going to weigh 0 pounds. 0 jam jars need 0 cups of sugar. So therefore, right, each graph, what do I observe? That each graph starts at the origin. So if you're dealing with a linear situation, a line, and you see that it starts at the origin, that's an indicator that you're going to have a constant or proportionality relationship, a proportional relationship between the two variables that you are comparing. Another important clue. Let's go at two equations that are also considered proportional. Here I see that Juan selling raffle tickets at a charity event for $6 each. So write an equation to determine the total cost for any number of tickets. Well, my cost is going to equal 6 times the number of tickets, or again, y equals 6 times x. Here, Cameron brought candy bars that cost $2.50 each. Write an equation to determine the cost of x number of candy bars. Well, again, the cost of the candy bars is $2.50 each. So my total cost would be $2.50 times x. So what do I observe? I observe that I have one-step equations here. And the fact that I'm dealing with one-step equations lets me know that I have a proportional situation and that I'm going to have a graph that passes through the origin. So let's go ahead and summarize all the characteristics that we have been observing about proportional characteristics. If I'm given a graph, what do I need to know? That my graph definitely is taking on a linear relationship, but more importantly, that where the graph starts, right? It starts at the origin. So if your graph starts at the origin, that's another huge indicator that we're dealing with a proportional situation. What do I need to recognize when I'm given a table? Well, what you need to do is you need to take your ordered pairs on that table and you need to divide the y coordinate over the x coordinate. If all your ratios are equal, then that means you have a proportional situation. You have found your constant, right? The k is known as your constant of proportionality, or even constant of variation. Okay? Check every point. If I tell you to go see which table is proportional, y divided by x. Okay? Equation, what you need to walk away with on an equation is if you have a one-step equation that looks like this, y equals k times x, k meaning your constant of proportionality or your constant rate of change, right? Your unit rate. So when they're multiplying by one particular rate, like $8.50 per t-shirt that we looked at, right? Or y equals 1/2 x, y equals negative 3x, okay? Any of those are examples, good examples that you have a one-step equation, one operation, and that means you're dealing with a linear proportional situation. These are the characteristics I need you to keep in mind. So you work on this assignment here. I'm giving you a table. So use your characteristics to determine whether or not the representations are proportional or not. Again, if I give you a table, what's your job? Go back and look at your characteristics. What should you be doing with each of your ratios, right? You should be dividing. If I give you a graph, what are you looking at? Where does the graph start? If I give you an equation, what type of an equation should you have? A one-step or a two-step? If I give you a table, what should you be doing with your x and y coordinate? All right, we will talk a little bit more about this in class tomorrow. Please make sure you show up to Zoom as these concepts are very important. Have a great day.